Beyond the Basics is a bit of a catch-all title, so it's a bit dangerous. So let's get to the list straight away of what I'm going to be talking about. There's a secret fifth item I'm going to have if we have time, but basically I want to tell you how to test in the editor, how you can deal with scale and static objects and this kind of stuff. We have a new camera API, which is pretty cool for doing image processing and whatnot. And I'm going to jump into some of my code for making custom modified planes and point clouds and all this kind of stuff. How do you go about that? And then depending on how we go for time, I've got some input code as well I might share, how to deal with UIs and this sort of stuff. So AR mock. So currently there's this pain point where if you're using ARFoundation, you have to build it and run it, and it kind of sucks, right? So in the current version of ARFoundation, if you download that, there's this AR code, it's called AR mock, and it's going to run a simulation for you within Unity, so you can do all sorts of testing. And I want to talk a little bit more about that, but first I'll just show you the main components. Actually, I'll take a step. So packages are awesome. It helps us deliver code, but it doesn't help us deliver samples, all right? So AR mock has some setup here. You want to create some planes and attach some components. How do we deliver that to you? Packages, Unity's default, we don't want all the packages to start adding menu items everywhere and all this kind of stuff. So what we have usually is we have these packages, but there's also an ARFoundation samples GitHub that you probably want to grab as well, and that has the other part of, okay, how do I glue all this together and how do I use it? We kind of keep the packages kind of clean and free of examples and whatnot. So if you want to use AR mock, this is straight from the sample scene. We can just throw in game objects here, which are planes, point clouds, reference points, whatever we want, put them wherever we want, and they will pretend to be real AR objects when we run. You can spawn them, you can do anything you want with them, so you can set up your own testing scenarios, basically. And you can do these sorts of things, like you can put jitter on it, you can make it lose tracking every now and then. So in some ways, this is actually more useful than testing on the phone, because most people don't deal with when you lose tracking. Most people are in this nice, brightly lit office testing every day, and then they release their thing and someone tries it in their dark bedroom and it doesn't work. And they have no error, feedback or anything like that. So I think this is actually more useful than testing on the device, or a good first step for you to start thinking about what happens when something goes wrong and things shift around and whatnot. And you can also, and part of this is you also simulate the session that goes with it. So you can, again, turn tracking on and off and make sure you deal with that correctly. Turn the planes on and off and make sure you just get that kind of full life cycle going. This is what it looks like. So you can see the planes doing crazy stuff and disappearing every now and then. And so I was talking about how it can highlight some issues. So right now we're putting down a reference point and a cube when you click. And we can see the issue now is, well, world understanding changes as you're looking around and planes shift up and down, but our cube just stays where it is and doesn't respond to this. And so this is, you learn your first pattern in AR, which is whenever you're placing something in the world, you child it underneath the reference point, because the reference point, which is the little axis gizmo, is updating and gets notified when something changes in the world. So when you're testing and you see things sinking into the ground or whatever, you should be going, okay, I need a reference point there and anchoring my object underneath that, even if I'm testing against a plane. Now, if you want the samples, like I said, there's a GitHub Samples thing here, which is pretty easy to find. You can just Google that, or use the link up the top. Actually, is excuse me for a second while I just get my notes on this one. I'm going to pop out of this for a second because I forgot what the first link was for. I think it's to the blog post. Yeah, so the URL, come on, you can do this. Okay. Yes, almost. It's coming on my feedback. There we are. So this URL, oh, I made a bad mistake. This URL goes to the blog post that announces AR mock, gives some background information. You can find this GitHub thing, just switch to the mock branch and you'll get just what I showed you before, a default setup which shows you how to use this, and then you can start pulling that into your own project and using it as well. And like I said, you need to have the ARFoundation package updated to the latest version for this to work as well. So that's an enormous pain point. Now these are two conflated topics, and they've often been shown together in a sense of scale if you've seen anything on this topic before. So I'll go through the scale part first. The core issue here is a lot of the content you use in AR is small. Like often you've got something that's on a tabletop. When people author assets, you do it in meters, and so you don't want to have enormous table, shrink a house down to your table. There are some systems in Unity that rely on real-world measurements. So physics, the particle system can be a bit iffy. Even lighting can rely on real-world units. So sometimes you run into issues when you take content and just shrink it down completely if it's been authored at a different scale. So we want to think about a general scale solution for Unity, and then make ContentAppearAt as the second part of that. So this is one way to illustrate the issue. So one way to solve this is to scale the AR session object, which is the parent of everything in AR land, just to scale that up and down. If we do that, then the objects don't necessarily come with it as it changes its position, right? So we don't want to scale the world and keep the objects the same. So the camera view of that same thing is our cube goes up and down and it's not staying nicely centered in the world. So what we do instead is, so the usual setup for ARFoundation is you have an AR session object, and you have your AR camera and everything underneath. We're going to move the AR session object to the center of what we're looking at, and then scale the camera, and everything's going to scale around the session object itself. So we can see the AR session object is actually where that land is, and as we scale, it means that everything scales correctly relative to that. It's a bit of a mind bender. It works. So you can do that. And there's support for that in ARFoundation for you just to make that happen. So here's scale and rotation, they all work. The one thing is though, it gets tricky once you have multiple objects. If I have separate planes and I put objects on both and I'm scaling the camera here and I'm pushing my session object in the middle, what happens to the wall where I've got another plane? So there are solutions to that. It's kind of a bit of a workaround. You might have to have another camera, for instance, and composite stuff together. But just so you know, that scale solution is built into the AR session object. That will do it for you, and it's available. But the bit I really wanted to tell you about, because I think this is kind of a bit of a corner case for scaling, is that the way you change where the session origin is to do this trick is this function here called make content appear at. So here we're going session origin make content appear at, and what that's going to do is it's not going to move mcontent. It's going to move the session origin so it appears like mcontent is at that position. Right? It's the reverse of what you'd expect. And this is just a useful thing to have anyway, because you can imagine now I can mark mcontent as static, and I might get some rendering efficiencies or some other efficiencies out of that, and I can just move the camera around to look at it. So you might consider, even if you're not scaling something, to use make content appear at rather than the way you're probably doing it now is when this is the case for when you tapping or something like that and you want to place something in a position, rather than just moving the thing, move the session origin. I can't tell you how much it annoys me that doesn't line up. But anyway. So that's hint number 2. The next one is the lightweight render pipeline. This, for the brief intro, is that this is our new render pipeline especially geared for mobile and VR. It's efficient, it batches better, you'll get a whole bunch of things out of it. It's in preview, so maybe not ready for your production projects yet, but we want to use it in AR. What does that mean? I mean, you can actually do that now out of the box. You can jam these things together to fiddle around a little bit, but we've just made it a little bit easier for you, and we've added support for the lightweight render pipeline in ARFoundation. And again, I'll just show you quickly how you could go about using it. I'll show you in action first. So I don't know if you've seen the shader graph examples. There's a GitHub repository which has the shader graph examples on it. I just pulled one of those down. So we've got ARFoundation with a shader graph shader running inside the lightweight render pipeline. And if you're not in production or about to release, I really recommend looking at this as a way to go forward. Just for performance reasons on its own, but then you also do get things like the shader graph and some of those newer lightweight render pipeline features, as well as if you saw my talk this morning, adding passes and doing all the other stuff you can do. Should have killed audio on this video. But anyway, there's a nice hologram shader in AR from the shader graph. Again, you've got go back to here or operate on branches here. It's the same samples as before, it's just a different branch, and you can pull that down and it'll have something set up for you. You don't have to do this. It's just, again, just to show you how to set it up, to give you an example of how to do it. What it does is, if you're using the default render, it just does whatever it used to do, has a renderer that does it. If you're using the lightweight render pipeline, it actually has its own render pass that renders the background with the material. That's all it's doing, it just takes care of the background. That's really the only issue we had, was the ability to swap between what renders the background or not. I've been encouraging lightweight render pipeline, just go and look at the blogs, because it does have different lighting and different materials, and so there is some kind of upgrade steps you need to go through if you're going to go down that path. Okay, so the camera API, this got asked for a lot. This was one of the first things that came up on the forums, is I want to do some computer vision, right? I want access to the camera and to do something with it. You've been able to get the camera background on the GPU easily for a while. I had a sample for a while where I was doing lighting, and that was, I'm going to show you this actually. So, this is the API for doing this. This is what you need to do. AR Subsystem Manager, for the ARFoundation has a bunch of subsystems. One's the camera one, and you can just hook an event saying, please tell me when a new camera frame arrives. This takes away, if you wanted to get the camera background before, you have to use command buffers and inject the command buffer at the right time, and it's a bit of a pain. This just lets you get, it's more a timing kind of thing, right? So here there's a few things I can do, and you don't need to use all of this code. This shows you a few different approaches. So once a frame's arrived, what can I do? I can get all the textures that are in use. Be careful, because they're different for different platforms. iOS has two textures, the YUV and the chroma, and Android AR Core just has one. But if you want access to those buffers, you can just go grab them and get pointers to those textures. That's still on the GPU, right? You're just getting access to textures. If you want to get them back onto the CPU, this is where it's a bit more painful, because usually when you have a texture on the GPU you want access to, we've got this camera background, then there's it can be performance, it can be heavy to try and copy that back. So we've just tried to make that as quick as possible. So you can, so once you've got those, you could do some things with them. This is still all thinking on the GPU. I could blit it to another texture, right? And the nice thing about this is, you can see here I'm going graphic split. So the nice thing about here is, camera frames received, all the materials and all the correct stuff is actually, all the render states set up for background rendering. All I need to do here is graphic split. I don't have to pass in the texture I'm blitting from, because it's actually got the right textures set up either on iOS or Android. And then if I don't have to put a material on the end, and I can just split it to something else I want. Or I could pass it to a compute shader, or I could do whatever I want. So you're just saying you can hook an event, get access to the textures. What if you wanted to get those textures to run some computer vision on it? Then this is what you need to do. Subsystem Manager, try get latest image. And this is going to do that thing of getting the current background, copying it over, and it's going to deal with the conversion from two textures to one or whatever. It's platform independent. And you'll just get this, you tell it how you want to convert it. Do I want an RGBA? Do I want it to mirror it? Do I want to flip it? Whatever. And then I can get actually a byte array back and feed that through to my computer vision APIs or whatever. So it just takes care of a bunch of mucking around. Okay, so I probably should have got in some warning on the code heaviness of this, but anyone who's been here knows me. So now we want to do some custom plane meshes. So the default plane's okay. It puts this yellow texture down, and it has a line renderer that goes around the outside. But you don't want your ARFoundation thing to look the same as everyone else's, right? You want to have some feedback. You want it to look pretty cool. You want it to give some feedback when someone places on there, have a little spotlight or do something there. How do I go and change what's going on. I mean, I can change the material that's on it. There's a prefab that's there, but if I want to do anything else, then I'd have to mess around a little bit with maybe meshes or UVs or something like that as well. So this is the first time I've used like any sort of class diagram in my slides. It's not official. I don't think that lightning bolt's actually official documentation, but just to make it really clear that there was an event. There's a few different classes, and so I thought this might make it clearer the chain that goes through. So ARFoundation is a lot about updating, right? Something changes in the world, we get some new understanding, we'll fire events up the chain, and you can do whatever you want with it. We've already seen that with the camera. Same goes here. If you've got an AR plane, it's going to tell you whenever it's updated, and you can do whatever you want with that news. You can move an object, you can do a raycast, you can update things. In ARFoundation, we have a mesh visualizer that's there by default. That's the one the default one you see when you go. There's a mesh visualizer that what it does is when it gets this event, all it gets is a series of points. It just says, here's the edge of the plane. It will go and build a mesh for you. It will optionally put the line render outside and generate UVs and do all the hard work, basically, of mesh generation. But we want to change that somehow. So how do we get in here and actually change how we generate our UVs, for instance, if we wanted to do something different? Maybe we want to do world space UVs or something. I could just write my own visualizer and generate meshes myself. That's totally fine. But the mesh visualizer itself also has an event saying, okay, when I finish generating the mesh, I'll let you know about that, and you can go mess with that in some way. So what I'm going to do is I'm going to have some custom plane visualizer here that messes around with it. And I've got a couple examples of that. Just to show you what that looks like in Unity land, we have an AR plane there. We have the plane visualizer, which generates the mesh. And then in this instance, I've got this is the feathered plane visualizer I wrote for the ARFoundation as well, that just has a nice, rather than having hard edges, it just fades out towards the boundaries. So let's look at the feather one first. So this is part of ARFoundation. This is something I contributed, and it's what we want to do is, the central idea behind this is when we're in AR, there really is no hard boundary to a plane. It's just gets kind of more vague as we go out. So I don't want to give the user an idea that the edge of the plane is a good place to be. I want to kind of fade out and just kind of, have it lying there. So how do we do this? What's the strategy? If I've been given a mesh that goes up to the edge, how do I generate a nice boundary around it that fades out? So what we want to do is use some UVs, right, to determine when I should fade out. I don't want to mess with the main UVs because I've got this nice blue texture on there, so I'm going to generate a second set of UVs here for the feathering. So here's some code to explain what's going on. You can see the top one is that I'm hooking that event there, the mesh updated event that I talked about before in that class diagram. And then once I have the mesh, it's just a Unity mesh, so I can get vertices, I can do any of the stuff. So what I do is I get all the vertices, I do some code here, it's not really important what it is, but basically it's a ratio from the edge that I'd like to the UV that I'd like. It's just some ratio maths. And then once I've calculated my second set of UVs, I set those back in the mesh. And then the last line is the shader code there that just is going to do the alpha from the second set of UVs out towards the edge. Again, details are not really important of how that's actually done, just to know you can hook that. You can use the mesh API to add more points, delete them, change things however you'd like. So I made this app called Faces on Things, which is an ARFoundation app which just lets you get silly hand-drawn faces and put them on things in the real world. I really like this plugin for Unity called Doodle Studio 95, ! Which is basically MS Paint inside Unity, and it lets you do these like little 3-frame animations. You just can draw there really sketchily, and I really wanted that look inside ARFoundation. So I'm like, well, how do I make this happen? How do I get this, you see these, the plane boundaries, they're sketchily hand-drawn, but they overlap, right? And you can see the point cloud is it's got a little 3-frame animation, and it just pops around, and it kind of gives a feel for the whole thing rather than using the default one. So how do I get this to happen? Again, it's the same method. I'm just going to write some code that's going to hook when the mesh is updated. But this time, instead of updating UVs, because I actually want to go outside the boundaries of the plane with these overlapping boundaries, I'm going to generate some sub-meshes. So for each edge, I'm going to just generate a quad that sits on it, an overlapping quad that sits on it, has its own set of UVs, and I'm going to set that as a submesh. Let's see what that looks like. Again, I don't want the details of the code to kind of distract us here. Top thing is just some of the code for generating those quads. And then, but here's the bit down the bottom that I just wanted to show you. Once I've just added extra vertices there, I just set them back, I set my UVs, and then this set triangles thing just creates a submesh within Unity. So, and then I can assign different materials to the edge and different materials to the middle. So again, it's just different ideas of how you can customize the look of your game or your ARFoundation experience. That's it. So I have time. Don't clap yet, because I'm going to go and show you something really quick, because I've got like a few minutes, I think. So all these examples here where it says if you've got a mouse button down or if you've pressed go do something, it breaks pretty quickly when you get UI in your game and, or in your experience. So I just wanted to show you one thing I did with this Faces on Things app, which is public on the web as well. If you want to have a look at these mesh generation stuff, you can just find my GitHub and pull it down. So let me just take just a few minutes to show you what's going on. So let me get out of these slides so it will let me duplicate my monitor. Okay. So this is the Faces on Things project. Now, Unity has this event system that I think is a little bit underutilized. It's part of the UI. It's used in the UI for firing buttons and doing all this sort of stuff. And it's got a ray card, this sort of stuff. But it's kind of just stayed in UI land, and no one really uses it outside of that. But I want to use it now to know whether I'm poking UI or whether I'm poking into the world. So we have an event system here, which just is automatically added when you add a UI thing. And like I said, most people just ignore it. Standalone input module takes care of mouse and touch input for you. And then the other part of this is you can have raycasters. So how do I know whether I'm over something? Well, the canvas has the graphics raycaster. And so the input system will use this to say, it will test whether something's over the UI or not, and then send a button event, for instance. Or the other part of this is, so if you do find something, you get I pointer down interface events, or I button down. And again, the UI just does this for you, but you can actually write code that does that as well yourself. So then my little thing for this is on the AR camera, I added a raycaster for ARFoundation. So what this does is this just gets automatically picked up, and it does ARFoundation raycast. I'll show you the code. And it then just reports to this event system whether it's hit something or not. And if it's hit something, it sends an on-touch event or an on-drag event or whatever part of the input process you're in. So feel free to steal this code. So you just to make a raycaster, you override base raycaster. And then the crux of the matter is, most of this is fairly boilerplate, is that somewhere I do a AR session origin raycast. I'll make that a bit bigger. So this is the same code I do something, but it just transforms, it just means the event system can know about it and use it. And that means I can go and write code like here, where I have a mono behavior which has an I_begin drag handler, an I_end drag handler. When I come down into these handlers, say on drag, I can just say, hey, that raycaster that sent this event, is that an ARFoundation raycast? Then I'm poking something in the world. If it's not, then I'm poking the UI. And so this lets me poke the UI, grab something, drag it off, drop it into the real world. And it's all just handled through begin and end events. And you can imagine doing that in your update loop. There's a lot of, check to see whether this event hit something, keep track of it, move between stuff. And so it just actually reduces the amount of code you have to write a lot. So there we go. So that's the summary of the things that have helped me out when I've been testing extra testing, lightweight render pipeline, moving the session origin around instead of the objects you want to move around, doing some image processing or camera API stuff for lighting or whatever you'd like, and then customizing ARFoundation by creating your own custom meshes, point clouds, reference points, etc. So, thanks very much.